Hello everyone. In our previous lecture, we have discussed about patterns, lexemes and tokens. So we saw that the tokens are described by the different patterns. Like say for example, an identifier token in a programming language can be defined by the pattern which says that it can have only characters, that is the characters of the English alphabet, and maybe in between it may have some special characters. Okay, but it cannot start with a digit, or it cannot start with a special symbol. So that is the pattern. Now to formalize this pattern, we have something called the regular expression. So in today's lecture, we are going to look at regular expressions. So what is a regular expression? Okay, as I mentioned, it is nothing but it is the patterns that you can use to identify tokens. So patterns of strings of characters. Now these patterns, when you represent it using a regular expression, what you get is a set. Okay, you have a set. Okay, and within that set will be all strings of that language that matches it, for which it is a match. So suppose I say my pattern is AB. Okay, in that case, the string AB will form a set, and this set will be defined as the language of that particular regular expression. So we write it like this: L of AB. So here AB is the pattern. Okay, AB is the pattern. In fact, it is also the regular expression. AB is the regular expression, and all strings that matches this pattern will form a set, a mathematical set, and this set is known as the language that is generated by that regular expression. Okay, so this is what we mean by a regular expression. Language will consist of something known as the alphabet. We have already discussed this before, and it is denoted by the symbol, summation symbol, sigma, capital sigma. All right, and this alphabet consists of certain symbols. Okay, let's say the alphabet of a language consists of the symbols A and B. Okay, so that means any valid token inside or for that particular language will only consist of the symbols A and B. Okay, nothing else. So when we talk about a programming language, the character set of that programming language forms the alphabet. Now, moving on to the next, let us see what are the components of a regular expression. So firstly, we have the symbols in the regular expression represents patterns. So what are the symbols? Like I mentioned again, summation, if the alphabet is of the symbols A and B, so A and B are certain symbols of that particular language, and these symbols will be used to form the regular expression. All right. Now, along with that, in the regular expression, we will have also certain characters known as meta characters, known as your meta characters. So what is this meta characters? These are some symbols which are used in addition to the symbols of the language. So if my summation, or that is the alphabet, is AB, so in my regular expression, I will have the symbols A, I will have the symbol B, all right? And in addition to this, I will also have the symbols star, then this is the pipe, then parenthesis. Okay, then there are also some more extended. We will talk about these later. So these symbols, extra symbols which are not there in the alphabet, these are known as your meta characters. So in your regular expression, all these will appear. All these will appear. So the symbols of the language, as well as the meta characters. Now you might be wondering that when we're talking about these meta characters like this star here, like the star here, this pipe here, these parentheses, okay? Now these may appear this may be a part of the alphabet. So I may have something like my language consists of A, B, and say star. Okay. Now in that case, what will star represent? Will it represent a symbol of the alphabet, or will it represent a meta character? So in situations like this, we use something known as a escape sequence. Let me just write it down here for you. We use something called escape sequence. So what is an escape sequence? Escape sequence is a special symbol which is used in front of these symbols which appear as a symbol as well as a meta character. So whenever I want a particular symbol in my regular expression to represent that symbol of the alphabet, then we have to precede it with an escape sequence. Okay, if there is no escape sequence in front of it, then we will know that this does not represent the symbol of the language. Instead, it represents a meta character. Say, for example, let me go to the next slide. Let me draw it here itself. So let's say my sigma here consists of A, B, and star. Okay. Now my meta characters also contains star. So I have to define an escape sequence. So my escape sequence can be, say, slash. So I use the escape sequence, slash as the escape sequence. So when I want to represent, suppose I want to say A star B. This is my regular expression. We will see how to construct later on. So if we write it like this, now here is this star representing the symbol here, or does it represent this meta character? So let's say we want it to represent the symbol. We want it to represent the symbol. Then we should write it as, we will have to write it as A escape sequence star B. So this means that here the star which is used is the symbol and not the meta character. But if I simply write it like this, A star B, then it means that this is the meta character. Okay, so that is about your about escape sequence and how we write the regular expression. Now let us look at the definition, or the more a recursive definition of the regular expression. So we start with like this. First, we start with a basic definition of the regular expression. So what is this basic definition? The basic definition says that single characters from the alphabet that matches itself is a regular expression. So single character that matches from the alphabet that matches itself. So if again, let's say my alphabet is AB, okay, then single character, that is A here, B here, each of this is a regular expression. So A here is a regular expression and it consists of the set. This is the only string which matches A. So I have, this is the language for A. So language for the regular expression A. Similarly, B is a single character from the alphabet. Okay, so B is a regular expression and the language generated by this regular expression is the string B. Okay, so this is your single character. So this is known as your basic regular expression. Now, once you have this, now we can have a recursive definition where we can use different operations. So what are the operations? The first operation is choice. Okay, so choice is represented by the pipe. Let me just, okay. Choice is represented by this pipe. Okay, so here I have seen that A is a regular expression and B is another regular expression. So when I write this, this whole regular expression, what it means that either the regular expression recognizes either A or B. So this is a or. So the A or you read it also as A or B. And in terms of language sets, because see here, like this is a set, this is another set. So A is this regular expression is represented by this set. This regular expression is represented by this set. So when we write A or B, what will be the set corresponding to it? That means it will have A is a valid element of the set. It can be, when B is a valid element of the set, so A comma B. So the set, the regular expression A or B recognizes the string A and the string B, both. So if it is A, then also it belongs to this regular expression. If it is B, then also it represents the same regular expression. So in terms of language, when we write L of A or B, we can write it as L of A union L of B. That's what it is. You can see from here. L of A is this, L of B is this. So L of A union L of B, you get AB. So for choice, you have the union. So let me just clear the screen before we go to the next operation. So the first recursive operation is choice. Next, we have concatenation, R dot S. So we already saw that A is a regular expression, B is a regular expression. What is the set? The set is A and the set is B for each of these. Okay. Now, concatenation, or we can write like this, AB. What is this? This is the strings from A followed by the strings of B. So you join together. First, you have to have the elements of A. Then this must be followed by the elements of B. So you can write the language generated by this regular expression AB as L of A followed by L of B. So this is concatenation. The third one is repetition, or also known as clean closure. So clean closure is, you can see the star represents the clean closure. So if R is a regular expression, so here let me put A is a regular expression, then A star, what it means? It means 0 or more repetitions of the regular expression that we give here. So let me write 0 or more reps of, in this case our regular expression is A, so 0 or more reps of A. 0 means I don't have any element. If that means I'm not going to repeat A, no repetition of A. So when it is no repetition of A, it means a special string known as epsilon, or this is also known as the empty string. Empty string. So empty string, we mean that it does not contain any character, no character. So epsilon. So if it is 0 times repetition, I have epsilon. If it is 1 time repetition, I have A. If it is 2 time repetition, I get AA. 3 times AAA, and so on. So it is infinite. Infinite number of terms, the string or the regular expression would be repeated. So that is your clean closure. So these are the different, this is what I have already explained. So it says, let me just rub this part. So it says, any finite concatenation of string, each of which matches R. So any finite number of strings, concatenation of strings. So here I have 0 concatenation, here I have 1, here I have 2, here I have 3, and so on. So this is your clean closure. So if I have to take an example, let me take an example here and show you this. So again, say I have A, B, and C. Okay. So A is a regular expression, B is a regular expression, C is a regular expression from the first basic definition. So it corresponds to the set A, it corresponds to the set B, corresponds to the set C. Then I can write A or B or C. Okay, so this regular expression corresponds to the set A, comma B, comma C because it is union of all of these. Then suppose I write something like this, A, B or C. Okay, that means it is, look at this, this is what? This is concatenation. This part is concatenation. So this is actually, this is a basic, this comes from the basic definition. This comes from the concatenation example or the concatenation operation. So here I can again break down A, B to be what? A followed by B, language of A followed by language of B. So I will have A, B here, or I can have C. I do not have A and B separately. Why? Because this is not separate. There is no choice between A and B. There is a concatenation between A and B. So A must come first, then B must come. Similarly, I cannot add BA because that is not our pattern. Our pattern is AB. So that is about choice, and concatenation also we have seen. Let's look at another example. Let's say A, comma, B star. Okay, A, comma, B star. So let's see here, what are the two options I have? First is I may have A, or I will have, let me just write it down. This is not a proper format, okay? Just for explanation, just for the stepwise showing, I am writing it like this. So I can have A and B star. Now what is B star? B star is nothing but epsilon B, BB, BBB, dot, 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 goes on any number of repetition. So what I get here is A, which comes from here, and for B, what I have epsilon, that is empty string, B, BB, BBB, and goes on like this. So this is a regular expression. What you see here, this is a regular expression using concatenation as well as your clean closure. Now, since there are operators, we have seen the three operators, or, let me write it here, or, then concatenation, even though dot is used, is not shown. So dot, and let me write star. So these are the three operators. Now in an expression, just like any mathematical expression, all three of them may appear. So in that case, and in addition to this, there is also something more, which is your parenthesis. Okay, you can combine these in parentheses, and they will do the exact same work as they do in mathematical operations. So here, what is the precedence? Which one will you execute first? Suppose you have a expression like this: A or B star C. Okay, you have concatenation. Here you have concatenation, you have choice, you have closure. So which one should be done first? So there is a precedence among these operators. So what is the precedence? Precedence is like this. First is your repetition. So first you will do this star. Okay, then comes concatenation, and then comes your choice. So choice has the last precedence. Okay, so this is about the precedence of the operators. Now precedence is important because they can give you two totally different options. Like, say for example, I use A or B star. Okay, or I may also write it like this: A or B star. Okay, now if precedence is not followed, then this too will give you a problem because they are not equivalent. If you look at A or B star, it will give you uh, the first one will give you A will be there. Okay. Uh, then of course just I will write it again. So since the whole thing is under star, that means 0 or more repetitions of A or B. So I have epsilon. Okay. Then I have A. Okay. Then I have B. All right. I have either A or B one time. Then I can have AB. All right. Or I can have BA. Okay. I can start with B and then I can go to A. Okay. Because it is repetition. Then I can have AAB. A repeat twice, then come with B. Or I may have B, 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 A, A. Okay, I can go on like this. So this is for this regular expression. For the next one, for the one here, I can write it like this. This says either it will be A or it will be B star. So if it is A, then A will be here. If it is B star, okay, then I don't have to repeat. I may not have to repeat, so epsilon will come. Okay, because there is a choice. I may choose to ignore A. So I will start with B star only. So if I start with B star, then I will have only epsilon, or I will have B, or I will have BB, or I will have BBB. But here you can see there is no combination with A. There is no combination with A. Because here you can see, as you see from here, the star is associated with B, not with the whole expression. Okay, so this is about why in your precedence is important. Now I will stop for this lecture. I'll stop here. In the next lecture, we will look at some other way of writing regular expressions, and we will do a whole bunch of examples.